And special thanks to Dr. Loeb for being here today and giving up his time and the dad in his break. So we want to give him Dr. Nelson, Pete Nelson would be here tonight, but he's away on business. But he sends his regards, and hopefully he will be able to make it before the evening is over. At this time, I would like to talk about a couple of events that you probably see in the flyer store that we have going on at the college. One of them is called Dream Big, which is a movie about engineering and the impact that engineers have on everyday life. Hopefully, you guys will take a look at the flyers that we have outside. The other one would be the Alumni Awards, which is coming up November 15th. Dream Big will be October 7th, if I missed the date. There's still time to RSVP. The other one would be the Alumni Awards, which we will have November 15th, and we welcome all of our alumni to come to that event as well. Without further ado, I'll introduce the Alumni Association's president, Jerry Meyerhoff.
Thank you, Maurice, and thanks everybody for coming. This is really a great turnout. I'm very thrilled. Welcome to Tech Talks. This is our third Tech Talk in our revised series. I'm Jerry Meyerhoff, and I'm the EAA president, not the entire Alumni Association. That's somebody else, and that's coming up. Just a quick show of hands. How many are students here in the audience? Oh, wow. Yeah, I love it. Great. And how many are faculty and staff? Good showing, good showing. And how many are alums who are out in the work world? Okay, thank you for, I know it's a little early to come in and do this, so I appreciate you coming by. We have a number of our officers with us. We have our secretary, Jonathan Koo. He's outside, you met him already. Our treasurer, Bill Hawes, is in transit, but he's busy planning some other things for us. Our VP of membership, we have Susan Aricello. The president-elect is David Clawwitter. There you go. And you already met our liaison, Maurice. And then coming up will be Dr. Brandon Hampton, who's our programs VP. We'll get to that in just a moment. We also have a number of members at large, board members at large. Let's see, I didn't see who was here. Did David Diener? No, I didn't see.
I'm not seeing Dave.
No, not today. And Luann Devine, she's running the camera, so that's good for us. So it's really cool to see a lot of people come up for these events. I was involved in running them in the prior years since the EAA was started in the low 70s when a bunch of us just graduated from UIC and said, wouldn't it be cool to have an engineering alumni association? And so we just started it organically, much like many things happened at UIC, where people took big risks and did new curriculum enhancements. So we're excited to see that EAA continues. We have a couple of key programs that we're doing to serve the College of Engineering, the student body, as well as alumni. We have a mentoring program where alumni coach undergraduates, and Rosanna Granada is our member at large who is managing that with the College of Engineering. And we already talked about that item, so we'll go on. Other things that the alumni do, we're judges at the Engineering Expo, and we're also involved in career prep. Maybe some of you saw yesterday a few of our representatives were there just to talk casually about it. You may or may not be aware the Alumni Association, the big Alumni Association, has been reorganized. It used to be one unit to serve all three major denominations, if you will, the campus. Now there will be a UIC, Alumni Association. So we will have ours. It's going to be great. And as Maurice said, there'll be a celebration on the 28th. So if you want to be involved and you just have some questions in general, see myself or any of the other officers that self-identify. Look for us. We have a website, of course, at UICEAA.com. And we're also on LinkedIn and Facebook. So you can find us and find our activities in there. And I appreciate you filling out the little interest and survey cards as well, just for our feedback, and also if you'd like to be in touch. So now to introduce Dr. Brandon Hamilton, who's our programs chair, and he'll take it from here. Thank you, Brandon.
All right, thank you.
Yeah, this is all I'm going to stand in front of you. I thought I'd spend maybe just a few minutes, 7 or 8 minutes, about big data. Some of you are aware of it, some of you may not be aware of it. So I thought, to make sure we all start off on the same foot, I was talking a little bit about it, big data. Some people call it data lakes. I don't know if you've heard that term as well, data lakes. We hope that it's not a data swamp, but so data lakes is another term.
Clean the swamp, right?
If you think back to, at least when I think back to when some of us got our PhD, we were always concerned about statistics of our research. The model of statistics was used to develop some sort of a framework to look at minimal data, and not minimal, but enough to where we could hypothesize about the whole population. And so we were as satisfied as we could be with that little data. But things have changed a little bit. We need to think a lot differently about how we do things. So we're now shaping information with this big data movement, or data lakes movement, as I said. So when you think that back to maybe as far as 1995, perhaps 14% of America was on the internet. If you fast forward to about 2000, maybe 25% of the world was on the internet. If I look at it today, I would say close to 99 or 100% of the people are on the internet. So we are very digital. There was a lot of paper anatomy before then, so we're much, much more digital. So why are we so digital now? Well, memory is less expensive, for one thing. So that's helping things a lot. We're aggregating data with multi-core processors now, so that's helping as well. There's also that cloud that you're hearing about. Many of us are communicating through the cloud. So some of these things are the movements that are allowing for these new complexities to be looked at in a different way. So you may hear, when you hear and read about big data, the 3 V's of big data. That's volume, high volume, high velocity, and high variety. Those are the 3 V's that you hear most, I think. I'll add to that, if you will, high velocities, because there's a quality initiative as well that has to be considered as you look at big data as a discovery tool, which Dr. Loeb will illuminate a lot more than me. So there's a lot more data out there than used to be. And it's allowing for extraordinarily new things to be done. So tonight is one discussion that we're going to have about that. Our next tech talk is actually going to take another look at this same phenomenon. So the internet has shaped things such that people communicated differently, and it was a humanity communication tool. But big data is transforming more how society processes information. So there's a difference there. Some people confuse big data with just the internet. It is different. We're talking now about more than communication, more than internet. We're talking about large bodies of information that help people take a look at things where we used to look at small amounts of data. Okay, so let me give you just a brief set of statistics just to motivate you if you're not already motivated. Before tonight, I kind of looked around at various companies that are very engaged in big data and big data analytics, and it was interesting to me that they're about 5% improved in their profitability and their productivity ratios. When you look at some of their financial reports, productivity and their profitability are about 5% better. So there's motivation for management. And that's not enough motivation. President Obama, before he left, did write a big data initiative. Some of you students here, if you want to look for a senior project, look it up in 2012. That's the date of when it was published. Okay, so he had a big data initiative that lists some various requirements as far as the government is concerned related to big data. You might want to look at that. Let me give you one medical motivation, since we're going to be talking medical tonight. In 2003, the Center for Disease Studies was very concerned about flu, and they were just kind of taking patient visits as their data source. And they were arriving at things, but there were lots of lags in the reporting of the visit and actual knowledge gained from those various reports. Interview in medicine, no, that's too long. If you're trying to track a flu epidemic, you want to get at the data a lot quicker than a week. You know, it's already a problem. So Google did a similar thing, and Google is more instantaneous about how they do it. Let me give you one more case study. Back in the late 2000, or early 2000s, about 2001, 2003, there was a study. It's written up, as a matter of fact, I think it's published in 2009 in Nature magazine. You might see a similar kind of study where IBM was looking at trying to work with the Canadian government, Canadian Parliament, and they were translating from French to English and English to French. And it got bogged down. The system got bogged down. It was just too much to do. Google did a similar thing with the entire European Union, all the different languages that go on in the European Union. And we're handling billions of bits of information with ease. Okay, so there are various players out here that are doing well in big data. For those of you who are research-based, and those of us like me that historically have done research, you're probably accustomed to trying to come up with correlations. You're always interested in the independent data and how it relates to the dependent data. And so we want to look at causes versus correlation. We want to look at the why versus the what now. You know, it's a different world with big data, and we need to start thinking about that. One word that I'll leave with you is datafy things. I was thinking about a clever word that I might use today, and that's my new word, datafy things. So there is a cycle of data now. You discover it, you bring it together and come up with a conglomerate of data. You have it in some kind of form now that you can query it, and then you store it in some sort of application which reports it, and the reports start all over again. So it goes through this cycle now. It's different than the system development life cycle some of you might recall. So without further ado then, let's bring up Dr. Loeb. I think now you're all smart, because when I was teaching, I used to learn that many students didn't read the assignment. So you now read the assignment. I just gave you the cliff notes. So Dr. Loeb is the John S. Gardner Chair, Professor of the head of the Department of Neurology and Rehabilitation at our very own UIC here. I met him April 28th at a golf course, Highland Park Country Club, and was fascinated that I wanted him to be my next best friend. And so we've grown to know each other. As a matter of fact, I see a few of my other friends here with him. And so I would like to bring him up, and please welcome him and give him your attention.
So wait. How do we get rid of that 15? There it goes. All right. Well, Brandon, thank you so much, and thanks all of you. I mean, there's some seats here of people like are standing in the back. You may not want to stand the whole time. Yeah, come on forward. Don't be shy. You can have my chair.
3, 4, 5, 6.
So again, I want to thank the Engineering Alumni Association, Brandon, and all of you for being here today. The picture here and my title slide is the building I work in on the other side, on the West Campus. It's the Neuropsychiatric Institute, and actually over this next year we're going to have our 75th anniversary celebration of this building. It's a unique building is because it's not only bringing together different modalities of neuroscience. For example, we're housed in the North Tower with neurosurgery. We call that the left hemisphere, the dominant hemisphere. Psychiatry is in the South Tower, so that's the not so dominant hemisphere. And you guys who know a little brain anatomy know the connection between the two hemispheres is called what? The corpus callosum. So when you walk through there, that's the corpus callosum. So come visit sometime. The cool thing is it's shaped like a brain. You can see as our picture here. To actually work in a building that's shaped like what you work on is kind of fun. So I want to talk about a model system for studying big data, and really we're interested in the human brain. What better system to actually study big data? And I need to tell you a little bit about the disease that we study, epilepsy. Many of you know people who have seizures. Some people have pets, dogs who have seizures. It's a very common disorder. About 1% of the world's population has chronic or recurrent seizures or epilepsy. A single seizure is the clinical manifestation of hypersynchrony in the brain. And that's when basically millions, if not billions of neurons start firing at the exact same point in time. And the way we measure these populations of neurons that are abnormally firing to produce this seizure activity is through field potential recordings, putting an electrode on the skin, the scalp, or directly on the brain surface to record this classic spike in wave. So this is just like you'd see if you put an EKG strip on, you'd see this sharp and slow wave, or the QRS complex. So the idea with epilepsy in many cases that are non-generalized, there's a focus, there's a part in the brain where the seizures originate, and then it spreads because the brain is an electrical organ, and as it spreads you see the clinical manifestations of the shaking and convulsions that many of you think about with seizures. So this would be the idea of the focus, and this would be the spread of activity. So I'm going to start out with a video for those who've not seen somebody actually have a seizure, because it's actually pretty dramatic and pretty scary when you don't expect it. So this boy is actually having a seizure right now. Movements of his mouth are called automatisms, and it's part of what we see when the seizures start in the temporal lobe. As the electrical activity spreads to his motor area in the frontal lobe, he has what's called a forced head deviation, where his head pushes to the opposite side towards his left. And then as the electrical activity spreads even further, you get the classic tonic when all the muscles constrict at the same time, often occurring with tongue-biting incontinence, followed by clonic movements. And this is actually being done on purpose, because this boy actually has about 100 electrodes on half his brain, so that we can try to localize where that focus is, where are those seizures coming from. So in a second surgical procedure, we can remove that focus, and that's the only